Welcome to Case Study ex1, where we'll walk through how to apply key operators in RxJava's Observable class. Case Study ex1 explores calls to observable operators such as just, from array, from callable, from iterable, map, do on next, merge with, repeat, and blocking subscribe to create, reduce, multiply, and display big fraction objects synchronously. You can find all the source code for Case Study ex1 in the link at the bottom of this slide. We're now in my IntelliJ project for Case Study ex1. Let's start by taking a look at the ex1 file itself, which is the main entry point into this test program. As you can see, there are three methods under test. Test fraction multiplication sync1, which tests big fraction multiplication using a synchronous observable stream. Test fraction multiplication sync2, which is another test of big fraction multiplication using a synchronous observable stream. And finally, test fraction multiplication sync3, which is a test of big fraction multiplication using a synchronous observable stream that merges results together via the merge with and repeat operators. As you can see, as always, once we register these methods under test, we run the tasks using the async task barrier, and then we call blocking get, which will have the calling thread wait until all the computations are done, at which point we print out the number of tests that ran successfully. Let's now go ahead and look at the observable ex class, which is where all the fun stuff happens. We start by taking a look at test fraction multiplication sync1, which creates a string builder, which we'll use to display all the results when we're done with our processing. We begin by using the just factor method operator to create a stream of big fractions, 4 in this case, as you can see. We then use the do on next action operator to log the contents of the computation that came from just, so we can indicate the thread where the operation is taking place, what's happening with the results of the reductions, and so on. We then go ahead and apply the map transforming operator, which will take each big fraction in turn and multiply it by a big reduced fraction, which, as you can see here, is a large fraction constant that we defined in a helper file. And then finally, we call blocking subscribe, which is the terminal operator that will initiate all the processing in the other operators in the stream and then handle the results. This call will run synchronously since the publisher, which is just, is synchronous, runs in the calling thread, and blocking subscribe doesn't return until the final completion event is received. We'll see some other examples later that show more interesting types of publishers that enable asynchrony when we get to later lessons in the observable portion of this course. As you can see here, when the next event comes through successfully, its multiplied big fraction is appended to the end of the string builder. If an error happens to occur, then at that point, we're going to terminate processing and append the error message to the end of the stream or to the end of the string builder, and then display the results. And then finally, if we get a completion event indicating everything completed successfully, then we go ahead and convert the string builder into a string and display that as well. Since everything is performed synchronously, we're just going to return a constant called s void c, which is a completed completable, and that's an indication to the async task barrier that this method is done. Let's now go ahead and take a look at the next method under test, which is test fraction multiplication sync2. This is very similar to test fraction multiplication sync1, the main difference being that in this case, we're going to create a list of big fractions using the list of factor method operator on the list interface. And then we're going to use the from iterable factor method operator instead of using just. So in this case, we use from iterable, passing in the big fraction list. That will generate a stream of big fractions. We use do on next to go ahead and log the contents of each of these by calling a helper method here. Then we use the map operator, which goes ahead and transforms the fraction by multiplying it by our big reduced fraction constant. And then finally, once again, we have blocking subscribe, which works exactly the same way as it did before. We have one parameter that's passed in as the first lambda expression, which is a consumer that will simply add the multiplied fraction to the string buffer. We have the error parameter, which is the second consumer, which could handle errors if they were to occur. And then finally, we go ahead and have the third parameter, which is a runnable, that will convert the string builder to a string and display the results. As before, these calls are synchronous since blocking subscribe is a synchronous call. So we simply return s void c as the indicator to the async task barrier that this method under test is finished. The third and final method under test is test fraction multiplication sync3. In this particular case, we create a random number generator. You'll see why we're going to do that in a moment. And then we go ahead and create ourselves an array of big fraction objects You might have a sense of why we're going to do that here in a moment. We're going to create an array because we're going to turn around and use the from array factor method operator to convert that big fraction array into an observable. And we store that in something we call F1. Then down here, we're going to, in this case, use observable from callable. Remember, that's that lazy bound factor method operator. And we're going to pass in a lambda expression that calls make big fraction. So this callable lambda expression will end up invoking the make big fraction method, which will generate a large random numerator and a much smaller random denominator, and then put those two things together to create a big fraction. And as you can see here, we're going to use the repeat combining operator to cause that from callable to make a random big fraction, in fact, a different random big fraction 4 times. So we're going to end up with 4 random big fractions. And we use from callable here so we can make this a lazily bound call, so it'll be different each time. It'll generate a different random number each time. We then take F1 and we combine that with F2, and we're going to combine it by using the merge with operator. So the merge with combining operator will combine those two. Then we print the results. We map everything by multiplying by the reduced big fraction. And then we go ahead and use blocking subscribe. As before, the blocking subscribe is essentially the same. We're going to take each of those big fractions and append them to the string builder. When things go well, we're going to append an error message if things go awry. And if everything completes successfully, we will go ahead and display the results. Once again, this is a synchronous call since blocking subscribe is synchronous. So we simply return S void C. So now that we've shown the code, let's go ahead and run the code, and you can see what the results are going to be. And I think there shouldn't be too much of a surprise here. You can see we call test fraction multiplication sync1, and here are the intermediate results that are logged, and then the last 4 are the results that we get as the results from the call to blocking subscribe. Here's test fraction multiplication sync2, basically does the same thing. Notice, by the way, that all the calls are taking place in thread 1, which is the main thread. Remember that when we look at subsequent case studies where we have things running asynchronously in background threads and doing work in the background and printing results in the background. And then finally, we have the results for test fraction multiplication sync3, which, as you can see, has a larger number of big fractions being created. The previous 2 had 4. This one has 8 because we create 4 from the big fraction array. And then we also randomly create 4 much larger big fractions. And you can see here when we go ahead and print the results after merging them together that the first 4 show up at the beginning. Those are the ones that come out of the array. And then the next 4 are the ones that come out of the make big fraction factory method that we called using repeat. In this particular case, you can see there is no interleaving, but it's possible for interleaving to occur with merge with. And if you don't want to get interleaving, remember you can always use concat with to avoid that interleaving. In this case, we don't have interleaving, and that's primarily because everything is called synchronously. So that's the end of the walkthrough for case study ex1. Hopefully you now know a bit more about some of the fundamental operators that are defined in RxJava's observable class.